Okay, well, welcome back. What we're going to be doing today is 1-3, part B. So we're real numbers and number line. Okay, today's going to be really heavy in vocabulary, so you have to bear with me, and a lot of this is going to be kind of jot down as you go, so make sure you're kind of paying attention, especially today with all the new words. Okay, the objective today is to classify, graph, and compare real numbers. And again, we're still preparing for A1.4.2, so still a lot of review. Okay, first couple of vocabulary here is we talk about the set. Okay, set is the defined group of objects. Okay, so if we were to talk about -3, -2, -1, 0, 1, 2, 3, a group of numbers, that's going to be called a set. Okay, if you think baseball cards, they have a set of cards means that you have every card and it's a complete set. That would be kind of what you're talking about. Okay, an element of a set is each object in a set is an element of that set. So again, referencing back to those baseball cards, if you have a Barry Larkin card, that's an element of that baseball card set. Okay, -1, if you look up at the set above, -1 is an element of that set. Okay, it's in there. Okay, a subset, now a subset is a small group of elements from a set. Okay, so this would be like 1, 2, 3. That's a subset of numbers. So this would be like if we were talking school population. You have boys and girls, a set of students in a school. Well, if we were to pull out just the boys, that would be a subset. Okay, so if we were just talking about the boys, that's a subset. Each individual would be an element. Okay, hopefully that gives you a good idea of what each of those words mean. Okay, the next thing we're doing is classifying real numbers. So what I want you to do is take a second, think of a number. Okay, think of a number there. Okay, that number that you just thought of, the odds are that what you thought about is a real number. Okay, so what you just picked out is a real number, because that's all you know so far. Okay, real numbers can be broken down into 5 groups or subsets. Okay, 5 groups or subsets. Okay, the first one is counting/natural numbers. Counting/natural numbers. The second one is whole numbers. The third one is integers. The fourth one is rational numbers. And the fifth one is irrational numbers. Okay, so that's what we're talking about. Okay, so we're going to start breaking this down. So you're going to have to do a little bit of flip-flopping here as we go, because this is we're going to talk about the definitions as we do this. Okay, the first set that we have here is the counting/natural numbers. Now that's in this inner box. Okay, the most inner box, and that consists of numbers 1, 2, 3. Okay, those are natural numbers, or we call them counting numbers. It's kind of like hide and seek. When you go out and play hide and seek, you don't count 0, 1, 2, 3. You don't say -1, -2. You say 1, 2. You probably do the skip a few. Okay, and then you get the 100. But the natural numbers are how you naturally count. Okay, so that's in the inner set. So now when we come out to this purple box here, that's containing this interior set. So you're going to notice that 1, 2, 3 are still in there. Okay, it's containing that. But we added in what number do you see there? Yeah, that's right, you saw a 0. Okay, when we add in the 0, that's where we get the whole numbers. Okay, so whole numbers are natural numbers and including 0. So you're going to add that to your vocab list there at the top of the front page. Okay, then we get down to here and we have integers. Now integers are anything whole, so it's all the whole numbers, but it also contains their opposites. So if you look over there, you'll see some negatives there. So it's whole numbers and their opposites. So if one's an integer, so is -1. Okay, and so forth all the way through. Now notice that each one, as we go up, 1, 2, 3 is contained here, and it's contained here. So these boxes are packed within each of the next box. Okay, so they're always containing what's inside it. So the one here is rational numbers. Now the definition for rational numbers is anything that can be written as a fraction. So you're going to say, well, wait a minute, I see some decimals down there. Well, technically 0.222, that is 2/9. Okay, it's going to be repeating, or it's going to be, a terminating decimal. Those do count. Okay, so if it does repeat or terminate, like stop, okay, like 0.222, it stops after that, that is a rational. It can be written as a fraction. Okay, rational numbers can be written as a fraction. However, what you'll notice is that rational numbers include integers, whole numbers, and natural numbers. It includes everything. Okay, and then the last one that we have over here, the last box that technically you see is this one on the side. Those are irrational. Those are containing the numbers that cannot be written as fractions. For instance, radical 2 or the ever famous pi. Okay, that's the pi symbol, 3.14. Okay, those are irrational because they do not stop terminating as a decimal, and you cannot write them as a fraction. So you have to keep that in mind. Okay, and what you'll notice at the top, everything is in this blue box, which means everything here is real. So that number you thought of earlier, it's probably in this list. Okay, what you're going to notice though is that if you're on this outside, okay, does not mean you're on the inside here. So if you're a rational number, does not mean you're an integer, a whole number, or a natural number. For example, 0.222, is that an integer? No, it's not. Is it a whole number? Definitely not. Okay, so therefore it's not natural. However, if you're on the inside, you're inside the whole number box, you're inside the integer box, and you're inside the rational box. So therefore you're everything. So you can go inside is everything on the outside. You're packed all the way in the middle. Okay, so you got to keep that in mind as you work through that. And then everything in this list, even the irrationals, are real numbers. Okay, so let's look at this and let's do some practice as we go through. Okay, if we look at to which subsets or real numbers does each number belong, we're going to go ahead and say, this is real. Okay, and sometimes you're going to see it like this. It looks like an R with an extra bar on the side. Okay, that's how we kind of represent real. You can write out real, that's fine. Okay, so as we look at this list, we want to say, all right, well, what other numbers does 15 belong to? So the question is, let's start on the inside. Is it natural? Is it a counting number? Yeah, you would count to 15. So we could say natural or counting. And again, it's some symbols you might see is like a little N with another line. Okay, we write natural. You can write the word as well. I'll go ahead. Real, natural. Okay, so therefore, is it an integer? Yeah, it's a positive number. It's a whole number there. It's an integer. Okay, so we have I. I guess we should have gone to whole number as well. Okay, whole is just kind of the whole. Integer is an I. So you can use these first letters to represent it. That's fine for your homework. Is it rational? Yeah, well, this is one that people forget, is that, 15 over 1, that is a fraction. So therefore, it is rational. Okay, well, let's go over here to this one. Part B. Is that a real number? Well, yeah, it is. Okay, so we'll say it's real. Everything's real that we know so far. Okay, is it a counting number, a rational or a natural number? No, I wouldn't count negative 1.4. That's kind of weird. I would not do that. So it's not this. Okay, is it an integer? No, it's not an integer because it's not a whole number there. So therefore, I answer that question as well. It's not a whole number. Is it rational? Well, notice that it stopped. It terminated. So therefore, it is rational. Okay, it didn't keep going. If this would have been like a random numbers with a couple dots, now that would be irrational, but that wasn't there. Okay, let's go to part C, radical 57. So the question is radical 57 a perfect square? So we looked at that the other day. It's not a perfect square. We don't have that on our list. So as we go through, we can say, is it real? Well, yeah, it's definitely real. Hence by the question of the real numbers. It is real because that's what we're talking about. But it is irrational. Okay, because it doesn't terminate. Anything of a radical, as long as it doesn't simplify down, it is going to be irrational. Okay, again, hopefully that answered all your questions. If not, hit up my webpage, shoot out a question on discussion board and see if someone can help you, or hit me up on Twitter. If you can hold off, we can talk tomorrow in class. We'll have a little discussion and we'll pick up from there and do some work. Okay, have a great night.